Along the Silk Road, merchants from many different lands met each other and traded not only goods, but also ideas and knowledge. Despite the many languages spoken along the route, there was one language that helped them all communicate. It was the language of mathematics. For example, Indian merchants traveling to Egypt would have likely spoken either Hindi or Gujarati, and Egyptian merchants traveling to China would have most likely spoken Arabic. These merchants also knew the language of mathematics. They used a system of numbers and symbols to communicate complex ideas, quantities, and measurements. This system is known as Hindu-Arabic numerals, and its symbols are the ones we still use today: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Without these symbols, it would be difficult to imagine how global trade could function. But that's not all. Along the Silk Road, merchants traded all kinds of goods and services, including time. Time was a very important commodity. Travelers needed to know the time to plan their journeys and to coordinate with other merchants. But there was a problem. The sun doesn't shine equally strong at noon in India as it does in Egypt. The sun's intensity varies from place to place and from season to season. So how could merchants keep accurate track of time across such vast distances? To solve this problem, they developed the concept of time zones. Let us go back to the days when the only way to tell the time was by looking at the sun. Imagine you're an Indian merchant in Samarkand, which is now Uzbekistan. At noon, when the sun is highest in the sky, you see a Chinese merchant whose sundial indicates that it's only 11 o'clock. How can this be? You think to yourself, there must be some other explanation besides the fact that your watches are 1 hour apart. You reason that since you and the Chinese merchant are in different locations on the earth, the sun must be higher in the sky for you than for him at the same time. In other words, where you are, it's noon, but where the Chinese merchant is, it's only 11 o'clock. Because of this, you conclude that the Earth must be divided into 24 sections or time zones. Each time zone is equivalent to 15 degrees of longitude. Today, we have a total of 27 time zones, but the concept remains the same. From India to Egypt, merchants used mathematics to measure and divide up time. They also used it to measure the length of a year and the duration of time. They even developed the world's first mechanical clocks. So the next time you look at your wristwatch or phone to check the time,